Good morning, students. Today we'll continue with Unit 6, Lesson 6, and within Unit 6 we'll continue with Theorem 3, which states as follows. If two tangents intersect at the exterior of a circle, then the measure of the angle formed is going to be 1/2 the positive difference of the measures of the intercepted arcs. So what does that mean? First of all, we need to have two tangent lines, and we also need to have a circle. And of course, the tangent lines and the circles are going to be on the same plane, so they are coplanar. So in this figure, we see that tangents YN and tangents ZN, they're both tangent lines. Why? Because they're touching or intersecting the circle at exactly one point, okay? And they're also intersecting outside of the circle at point N. You can see it right here. So that means that the angle formed, which is YNZ, the angle formed as the product of the intersection of the two tangent lines is going to be, again, equal to 1/2 of the measure of the intercepted arcs. That is, if we see this example, the angle formed by the intersection of the two tangent lines, which is angle YNZ, is going to be equal to 1/2 times the difference of the measures of the two arcs it's intercepting. So in this case, the measure of the angle is going to be 1/2 of the measure of arc YMZ minus the measure of arc YZ. So if the given measures, the first one for YMZ is 250, and the second one, which is the measure for YZ, is equal to 110, you simply substitute the values. So that means that the measure of angle YNZ is going to be 1/2 of the difference of the intercepted arcs, which is going to be 250 minus 110, which is 140. So 1/2 of 140 is going to be equal to 70 degrees. Now we move on to our next sample problem. We have to find the measure of angle NPM if the measure of arc NQM is going to be equal to 298 and the measure of NM is going to be equal to 62. So the solution is we just simply substitute the measures of the two intercepted arcs in our equation according to Theorem 3. Which tells us that the measure of angle NPM, which is the angle formed as a product of the intersection of the two tangents, it's going to be 1/2 of the measure of NQM, which is 298, minus the measure of arc NM, which is equal to 62. So we just plug in the values. 298 minus 62 is 236. And then 1/2 of 236 is going to be equal to 118, which corresponds to the measure of angle NPM. And now we move on to our Theorem 4, which states that if two secants intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay, so recall the definition of a vertical angle. So in this case, we have two secants that are intersecting inside of the circle at point A. Very important you notice here, point A does not represent the middle of the circle or the center of the circle, which is right here. Point A simply represents the intersection of your two secants or your two red lines illustrated here in this model. Okay, so if we have angle 1 here, the vertical angle to angle 1, which is equal to the opposite angle, would be angle A. Okay, we also have angle 2, and the vertical angle to angle 2, it's the opposite angle. It's going to be on the opposite side, which would be this angle here. Okay, so we also have to notice by the intersection of these two secants that angles 1 and 2 form a linear pair. Why? Because they have this vertex, which is point A, in common, and they both share a common side or a common ray. Now, since angles 1 and 2 are a linear pair, that means that the sum of the measures of angles 1 and 2 is going to be equal to 180, because by definition, a linear pair is formed by two angles for which when you sum them, the measure is going to be equal to 180. That means that if 1 and 2 are a linear pair, that means that the measure of angle 1 plus the measure of angle 2 is equal to 180. The same thing happens here with angles 2 and 8. The measure of angle 2 plus the measure of this angle A is also going to be equal to 180, because angles 2 and angle DAC would also be a linear pair. So going back to the definition of Theorem 4. In this figure, we have secants EC and BD. Okay? They're both secant lines intersecting inside of the circle at point A. Okay? Notice here that arc BE is the intercepted arc of angle 1. And we also see here that arc CD is the intercepted arc, of angle DAC. And we also discussed the fact that angles 1 and DAC are what? They're called vertical angles. Okay? So let's see what happens. Okay? Here, the measure of angle 1 is going to be equal to 1/2 of the sum of the measures of arcs BE, which is the arc intercepted by angle 1, plus the arc intercepted by angle A, which is vertical to angle 1. So by definition, the measure of angle 1 is going to be equal to 1/2 of the sum of the measure of arcs BE plus the measure of arc CD. Okay? Notice that EB, again, and CD are the arcs intercepted by vertical angles 1 and A. Now, angle 2, the measure of angle 2 is going to be equal to 1/2 of the measure of arc BC, which is intercepted by angle 2, plus the measure of arc ED, which is the arc intercepted by this angle right here. So the measure of angle 2 is going to be equal to 1/2 of the sum of the measure of arcs BC and ED. Okay? Now, let's complete the example by substituting given angles for the measures of each of the arcs. Okay? Now, if the measure of arc BE is equal to 100 and the measure of arc CD is equal to 120, the measure of angle 1 is going to be equal to 1/2 of the measure of what? The measure of arc BE, which is 100, plus the measure of arc CD or DC, which is equal to 120. So 100 plus 120 equals 220, and 1/2 of 220 is 110. The same thing we do for the measure of angle 2. Notice that angle 2, this is its vertical angle. So angle 2 is intercepting BC, which measures 60, and this angle is intercepting arc ED, which measures 80. So then we take the measure of angle 2, we substitute the values, is going to be equal to 1/2 of 60 plus 80, which is equal to 1/2 of 140, and 1/2 of 140 is going to be equal to 70 degrees. Okay? Now we'll continue with our final example. It's related to theorem number 4, and as a matter of fact, it's problem number 4 in your assigned problems, which are in your hyperlink at your end of your presentation. So in this case, this is our illustration or our model, okay? Notice here that we have secants AB and CD. Remember that by definition, a secant can be a line, it can also be a line segment, and it can also be a what? A ray. So here we have the intersection, okay, of these two secants, and they intersect inside of the circle, okay? So they're telling us that if the measure of arc AC is equal to 39 degrees, and if the measure of arc BD is equal to 73 degrees, we have to find the measure of angle AED. Okay? Now, very important, the fact that the first thing we have to notice for this problem is that, first of all, we're not looking for AEC or we're not looking for DEB. Okay? We're looking for A here, ED. So we're looking for the measure of this angle. So that means that by the definition of a linear pair, AED and AEC, they both are a linear pair, okay? And by the definition of a linear pair, we know that the sum of the measures of the two angles that constitute a linear pair, they are supplementary, so the sum of those measures is always going to be equal to 180 degrees, okay? Now, here, by solving for the measure of angle AED, it's going to be equal to 180 minus the measure of AEC. Okay? So here, if we substitute in our equation, the measure of angle AED is going to be equal to 180 minus the measure of angle AEC. But what happens here? The measure of AEC, this angle is vertical. AEC is vertical or opposite to DEB. So that means that the measure of angle AEC is going to be equal to 1/2 of the sum of the arcs it intercepts. That means it's going to be equal, the measure of AEC is going to be equal to 1/2 of arc AC, which is intercepted by this arc, AEC, plus the measure of arc DB, which is the arc intercepted by this vertical angle, which is DEB. Okay? So here we have the measure of AEC is going to be equal to 1/2 of AC, which is the intercepted arc of vertical angle number 1, plus the measure of arc DB, which is the arc intercepted by this vertical angle. Okay? So it's going to be 1/2. These two values are given. 1/2 of 39 plus 73, which is going to be equal to 56 degrees. So that means plugging in the value of the measure of arc AEC, the measure of AED is going to be equal to 180 minus 56 degrees, or 124 degrees. Okay? So we'll leave it here. We'll continue tomorrow with theorems 5 and 6. Have a great day.